Hello and welcome back. Today we'll be doing question 6 from the 2018 BMO1 paper. Let's get started. Question 6. Ada the ant starts at a point O on a plane. At the start of each minute, she chooses north, south, east or west and marches 1 meter in that direction. At the end of 2018 minutes, she finds herself back at O. Let n be the number of possible journeys which she could have made. What is the highest power of 10 which divides n? Pause the video to have a think, and once you're ready, restart to see if you were correct. Let's get started with the first step in the question. Firstly, we want to describe Ada's position over time, and we can do this as a set of planar Cartesian coordinates, that is, xy coordinates. Ada will start at O, the origin, which is 0, 0 on the plane, and moves according to the rules. Each minute, either x or y increases or decreases by 1. We could attempt to count the possibilities for the lists of x and y coordinates over time, but we'd run into the big issue of counting how many times each of them changed. This is unnecessary and adds an indeterminate variable into our equations. Instead, we want two linearly independent metrics based off both x and y so that they both change every step Ada takes. One such example is to use the metrics u is equal to x plus y and v is equal to x minus y. U and v may vary independently of each other, and together they can determine a unique x and y, where x is equal to u plus v all over 2 and y is equal to u minus v all over 2. Each step Ada takes will cause u and v to change by plus minus 1 independently of each other. Notice that we must start and end at xy is equal to 0, 0, so we must start and end at uv is equal to 0, 0, meaning that u and v could have taken 2018 choose 1009 parts each. Thus, Ada could have taken a total of n is equal to 2018 choose 1009 squared parts. All that's left is to now calculate the number of tens which appear in the prime factorization. Firstly, we will take a look at the component 2018 choose 1009. This is equal to the factorial of 2018 over the square of the factorial of 1009. We'll set this equal to 5 to the little k multiplied by 2 to the big K multiplied by c, where c is a number that does not contain 2's or 5's in its prime factorization. Firstly, we will evaluate the number of 2's in this expression. There are 1009 even numbers, 504 multiples of 4, 252 multiples of 8, etc., and all the way up to 1 multiple of 1024. In total, the numerator has 2011 2's in its prime factorization, and the denominator has 1002 2's in its prime factorization, but it needs to be squared. Thus, big K is equal to 2011, take away 2 times 1002, which is equal to 7. We can apply a similar logic with the number of 5's in this expression. 2018 over 5 is 403 when rounded down, and we can do this iteratively to get that there are 502 5's in the numerator and 250 times 2 5's in the denominator. Therefore, little k is equal to 502, take 2 times 250, which is equal to 2. Therefore, in total, the expression 2018 choose 1009 is equal to 5 squared times 2 to the 7 times c, where c is a number that does not contain 2 or 5 in its prime factorization, and therefore it is equal to 10 squared times c prime, where c prime does not have any 10's in its factorization. Thus, the total number of parts n, which is equal to 2018 choose 1009 all squared, is equal to 10 to the 4 times the square of c prime. Thus, the greatest power of 4 that fits into the number of parts is 4. If you liked our video, please like and subscribe, and we'll see you next time for some more fun maths problems. Thanks for watching, and goodbye.